representing corona motors. The aim of this experiment was to build a simple motor whose propulsion is based on corona discharge. We were then told to investigate the rotary motion and how it depends on relevant parameters, and then to optimize our design at a maximum speed for a fixed input voltage. So for very basic understanding, a corona motor is a cylinder placed on an axis and it has electrodes around it. The electrodes are charged with high voltage, and the high voltage electrodes spray charge onto the motor, which is then repelled by the negative charge, is repelled by the negative electrode, attracted by the positive electrode, and the cylinder spins upwards in this particular case. The positive electrode is also spraying out charge constantly, which then will neutralize the cylinder at that point, and then further spray more positive charge into it, which will then be repelled, and the process will repeat. The much more interesting phenomena that is occurring here is the phenomena of corona discharge. At sharp edges or sharp points on a conductive metal, the surface charge density, and thus the electric field strength at that point, is extremely high. And often it is strong enough to ionize the air around it. What that means is the electric field can get strong enough to rip a electron out of its valence electron out of its orbit of an air atom, and they get separated. After they have been separated, the electron and charged ion is then accelerated either towards or away from the electrode depending on its charge. So the free electron that has been that is out of its orbit will be imparted kinetic energy by the electric field, and if it is given enough kinetic energy, it is able to ionize another atom nearby, knocking another electron out and causing an avalanche effect. These ions that are being created then will eventually pass the charge to nearby areas of low potential. In our case, this can be in two types: either monopolar, from a charged electrode onto a cylinder which is neutral, or dipolar case from a charged electrode to another charged electrode. And for our particular case, we want to maximize the monopolar corona discharge, and minimize the dipolar discharge, as this is essentially charge that is being lost and not going into our cylinder, which will not rotate. So, arc discharge was seen in our experiments, and I would like to give an explanation beforehand. So, if enough air molecules are ionized in a region of charged particles, these particles, if enough of them are ionized between a region of two charged electrodes, there is a region of free moving electrons, and if there are a lot of them, they can create a sort of plasma which current is able to flow through, and that means that the electrode will discharge and a spark will be created. This is not good for our experiment, as we want the electrodes to retain their charge, as that is what will give them the force that will create the torque on the cylinder. So, for a demonstration, our basic model looks like the diagram on the board. Since we had to use a Van de Graaff generator, as we were not able to find a different source of voltage, our electrodes were positive charged and alternating with grounded electrodes. Our cylinder was lined with foil on the inside, and it was a plastic cylinder lined with foil on the outside and placed on top of an axis around which it could rotate. I would now like to talk about the importance of the actual aluminium foil. We experimentally found that the cylinder did not rotate without the presence of an aluminum foil. Now, if you think of it, as the ions are accelerated, a sort of ionic wind is created, and as these particles hit the cylinder, the ions, electrons, will impart some of their momentum onto the cylinder. However, our previous observation demonstrated that this process alone is not able to spin the cylinder. Now, the actual importance of the aluminium foil is that it helps the plastic insulator hold its charge. So what occurs is, if you have a conductive material next to a charged object, it will gain charge of the opposite type. So in this diagram, the foil that is right next to the positive electrode, the electrons will be attracted towards it, and that particular area will have sort of a negative charge. This negative charge will help the insulator hold on to some of the more positive charge, and only then will enough torque be able to create it to spin the actual electrode. So the experimental parameters we investigated were the distance of the electrode from the motor, the angle of the electrode relative to the motor, the number of electrodes that we used, the use of actual aluminium foil, and the position of the electrode. So the first prototype we built was quite simple. It had perpendicular wooden boards along which blades were placed. The usage of the blades provided us with a flat, sharp surface, which maximized the electric field at the sharp points. A Van de Graaff was used to provide, as I previously mentioned, a positive electrode and alternating ground electrode. The problem statement asked us for an optimization at a fixed voltage, which was achieved by running the Van de Graaff at its maximum belt speed. So, the force and hence the torque provided by the build-up of charge is inversely proportional to the distance between the electrode and the cylinder. But that is not the only effect that is in play here. The effect of corona discharge does not extend forever, and it only occurs within a particular area known as the ionization area. This zone is where, after which the electric field is not strong enough to actually ionize the air molecules. And as the distance from the source increases, the density of charged ions or electrons, and thus the charge they can spray on the actual cylinder, decreases exponentially. And even though there are two effects at play here, it was hypothesized that the exponential decay of the charged particles due to corona discharge will be more influential. Our results were in conjunction with that, where the closest distance had the highest angular velocity, which told us that for an optimal motor, the electrodes must be placed as close as possible to the cylinder without it coming in contact with the actual cylinder. So the second prototype we created was in order to investigate the effect of the angle of the electrodes. And we built a second prototype which would vary its angle relative to a line perpendicular to the motor running around the front area. So our angle that we defined was theta, and that is perpendicular to the surface of the motor. To rotate the angles, we drilled a hole at the place where the motor would sit, and just underneath the motor, it was drilled into and fixed to that place, and it was allowed to rotate around that axis. By doing so, we were able to this was the only way we could properly investigate the angle. If the drill was not at the exact same place as the cylinder, the angle would not actually have a tangential, when the angle would be at 90 degrees from, theta would be 90, it would not actually be tangential as it was further away. So our hypothesis was that the angular velocity should be greatest when the blade is tangential to the cylinder. Our results did not show this, and the discrepancy that we found was due to the spray of charge would actually decrease as the angle was increased too much. So at 90 degrees, all of the charge is not actually being sprayed onto the cylinder, and quite a few of it is being discharged onto the other electrode, the dipolar discharge that I previously mentioned, and that was not good for our experiment. And we found that the optimal angle was at 70 degrees, where the angular velocity was not. To investigate the number of electrodes, it was hypothesized that as the number of electrodes increases, the amount of charge lost between the connections will also increase. And as the number of electrodes increases, the distance between consecutive electrodes will reduce, and this will encourage more dipolar discharge, which is not good for the actual spinning of the cylinder. our experimental results were in conjunction with that, except for the discrepancy at 2 electrons. This discrepancy was explained by the fact that the introduction of another ground electrode provided us with an extra attractive force to the positive charge that has been sprayed onto the cylinder. When there were only 2 electrodes, one positive and one ground, the charge on the cylinder was only being repelled by the positive charge and was not being able to be attracted by a ground electrode. And by introducing this new ground electrode, we introduced this attractive effect, which increased the angular velocity. We aim to reduce friction by using a metallic rod, which is placed on top of a metallic cylinder, or metallic washer, sorry, and the opening underneath the cylinder was sanded smooth, and a thinner rod was used. To compare foil on the inside versus foil on the outside, it was seen that when the foil was placed on the outside, the arc discharge was observed, and what that told us was that the electrode was being discharged and there was no force created for the cylinder to stick. Our optimized motor was contained of a 3D printed design, which allowed us to have reliable and precise angles and distances. The plastic that was printed was an insulated material and prevented dipolar discharge, and the blades were allowed to be held perpendicular. Parts are shown on the slide. The blades were inserted inside the perpendicular stands, and it was held perpendicular with the case. To conclude, we found that the optimal number of electrodes was experimentally determined to be 2 positive electrodes and 2 grounded electrodes.
Thank you so much. That's really good. And we just need to thank you. Questions?
Hi, my name is Thomas Lesnik, and I will be opposing this one. So the first question: how did you generate the voltage?
It was used with the pantograph generator.
Okay, and you turned it by hand or?
Oh, no, the pantograph generator. So it's giving it a constant voltage from a power cord supply.
Oh, okay. Okay. So you stated what is the driving mechanism that moves the motor?
We believe it is electrostatic attraction and repulsion, so Coulomb forces.
Okay, thank you. Have you proved this?
We were able to find out that was not due to the ionic ring imparting momentum onto the cylinder, as when the foil was removed, the cylinder did not spin.
Okay. What was the optimized speed that you achieved?
We achieved 10.45 radians a second.
Okay, thank you. Can you show me slide number 13? What?
Sorry?
Yes. What did you predict this decay should be?
At theoretical value?
Yeah.
We were not able
But like function-wise?
Exponentially.
Exponential decay. Have you calculated the onset voltage of the corona to become? Okay. Okay. Further, did you try any other types of motor, not on the electrostatic force mechanism?
No, this was the only one.
Okay. Thank you. And to the number of electrodes, you stated that with the increasing number of electrodes, the rotor should move slower.
Yes, and that is what we experimented with now.
Okay.
Okay, thank you very much. And you've got your preparation time.
Okay, so again, my name is Thomas Lesnik. I am opposing this task. So let's again, we can read the problem statement. In the answers to PO, the simple motor's propulsion is based on corona discharge. Investigate how the rotor's motion depends on relevant parameters and optimize are designed for maximum speed at the fixed input voltage. Well, the reporters built the motor and did some optimization, tried to find parameters that would work better for higher speeds. And yes, so They started off by explaining what corona discharge is, but we found this explanation a bit lacking, as it did not go into the detail of the differences between the positive and negative corona discharge and so on. Further, it did not explain other interesting phenomena occurring in the corona discharge that is interesting on this part, on this task. They did not introduce a simple empirical models that are well known, such as Fick's law, describing the relationship of voltage needed for the corona to occur, and other relevant parameters by which they could explain their measured dependencies. They tried to measure a few and optimize a few relevant parameters such as distance of electrodes, angle, number of electrodes, and of course friction. So they did it, they showed us the experiment, but that is it. They did not explain the experiment. They did not explain why they expected to see an exponential decrease in the distance of electrode, the rotor-electrode distance. They did not explain why they expected the number of electrodes to slow down the motor. Further, we believe that they did not sufficiently prove their model to be electrostatic. Some empirical experiments or just some rough estimates would be fine to show us if the momentum exchange of the ions impacting of the rotor are even comparable with the electrostatic forces. They showed us the foil experiment, but did not explain why does it increase the rotor speed. Further, we believe that part of the optimization itself is trying to find a better solution, and that means even trying to build a different motor. Just a simple cross from aluminium with a nail through the ends would be enough, would be sufficient to build a corona motor. So they would work on the different principle. So they could try that and show us, So further in the discussion, I would like to go through some of the qualitative expectation that they stated in their presentation, explain corona discharge in a bit more detail, if there's time for that, and explain in more detail what they measured and why the dependencies look like they look. So we can move on to the discussion. Okay, so we could start by with corona discharge.
So you want to know the difference between positive and negative corona?
Well, let's start by let's just draw. Let's just start by simply with the basics. So, could corona discharge occur near plate electrode? Near a plate electrode.
Plate. It needs sharp points at which the electric field will be strong enough to ionize it.
Okay.
There can be
electric field ionizes there.
Sorry?
So, does the electric field ionize in the air?
It imparts energy, to the electron, which it can be released from its orbit.
Okay, I disagree. I believe that the ionization is due to some random effects, such as a high energy photon coming through or some random cosmic radiation, and the electric field just accelerates the different charges in different directions.
Both of these cases are possible. The random ionization could have been from a high energy photon, which could have separated the electron as well.
Okay.
But after a set voltage, it is possible for just the electric field to be strong enough to ionize the electron.
Okay, and did you work at this voltage?
Yes.
Okay. and you showed us some sparks.
Yes,
spark. Have you made sure or calculated to be sure that you did not work in the range where the electric sparks between the rotor and electrodes occur?
Yes, so it was in our case, at the optimized motor, the foil was placed inside an insulated plastic layer, and the arc discharge did not go through the actual plastic layer because the plastic did not provide us with free moving charge ions for the electricity to be discharged. It only occurred when the foil was on the outside.
Okay, and what effect does the coil itself have?
The foil?
Yes.
So the foil allows for it improves the amount of charge that will be held on to the plastic insulator.
Oh, so it increases the capacity of the rotor.
Yeah.
And I mean, have you tried, for example, just sketch out some rough estimates of approximating the electrode rotor with a capacitor?
No.
Okay. I believe that this could have been done to show at least some rough estimates for the force that the electrode rotor combination could create. Further, we can move on to your presentation and to the distance between electrodes. Can move on.
The force estimates you were talking about, what exactly would those be? You were talking about force estimates of force?
Yes.
Oh, Jesus.
Well, when you have a capacitor, you could calculate the energy it has from like what charge it has at what voltage, and from that you could say that if you release you could say that this charge is stuck on the rotor, and from that you could say, okay, it is pulled to the different electrodes, and by what force, and you would proportionally get to the torque it creates. Do you agree?
Yeah.
Okay. So we can look at the distance between electrodes, between electron and the rotor. So you stated that the decay shall be exponential.
Yeah.
What is your reasoning behind this?
It is simply because it's due to the avalanche effect that I was previously mentioned. The actual the free electrons that are accelerated by the electric field, the chance that they will be imparted enough kinetic energy to hit into a nearby atom and to ionize the different atom.
Okay. But I don't follow your.
So if you're asking if we had a formula,
No, I am asking for a qualitative reasoning. What you stated, you just said that there is some region, disruptive region, where the avalanches occur, but that region is extremely small. And what in your distances, that you measured, it was in millimeters.
yes.
Those are order of magnitude smaller. The disruptive region is order of magnitude smaller than the distances. So I don't see I don't follow your reason.
Do you think it will be exponential?
I do not.
You do not.
I think it shall be logarithm. Well,
What was the justification?
justification. Well, we can say that Corona started at the onset voltage defined by Peake's law, which is an empirical formula measured 400 years ago. And there the onset voltage is exponential. It's a logarithmic function of the distance divided by the radius of collision curvature of the electrons. So, and I think that this transfers through the voltage to the force, torque to the maximum velocity. Okay.
The problem we faced with that was finding out how much of that charge will be imparted onto the cylinder, and if we were able to know that, we could have done calculations. But figuring out what set of atoms and what set of atoms will be in the area next to
We do not need to calculate it. It's just an empirical formula where you just put the dimensions and stuff. But we can move on. We can move on to number of electrodes. Number of electrodes, could you show the graph, please? Okay, so you stated that you expected a decrease with number of electrodes. So what's this with?
Yes, that was an anomaly that I explained in my presentation on the next slide. Yep. So when there were just two of them, if there were just two of them, with this being the positive and this being the ground, the charge that was sprayed onto here was only being repelled by that electrode and was not being able to be attracted by the ground electrode. By introducing this new...
But it would be repelled by this electrode?
Yes, it would.
Okay.
But the presence of this other ground electrode increases that.
Yes.
Yes.
Okay.
That's why the anomaly.
Okay. Okay. Well, I do not think that this is an anomaly. I believe that if you use a large diameter, you would see that with increasing the number of electrodes, you would see a greater speed.
Yes, but in that case, if you're increasing the actual distance of this, that will increase the torque, and that will increase the speed. So that's sort of not a valid experiment because you're not keeping everything constant. You just change the diameter of the cylinder.
Okay, but I understand what you're saying, but I mean that what you call an anomaly, I believe that is a main mechanism that's the force pushing the rotor. Like I put more things punching the rotor, it will rotate faster.
But the thing that constant voltage, that was in the problem statement, that constant voltage, and if you're going to spread those across differently, then each electrode will have like the lower voltage because it will be divided among all of them. But the one thing that was changing was the amount of connections that we had when we were attaching all of these electrodes to the battery. And
okay, I think we just moving in circles. Okay, we can move on. And I would just ask a question. Have you have you measured the damping of your rotor without electric field, without turned-on generator?
Sorry, as in damping?
Yeah, damping, the acceleration.
Yeah, we did.
You did?
Yes.
And so you could estimate what was the torque you created by your motor.
No, that would allow us to. The acceleration would just tell us how much friction there is because the first force is not very.
Thank you very much. It's time for the apprentice to sum up.
Okay, so I will sum up the last 2 points that we went through a lot of presentation, in part that will explain it, and moved through a lot of stuff. I would like to state a few things to the last 2 points with the number of electrodes. Well, maybe we misunderstood with each other with the reporter. What I meant was that what he calls an anomaly, I call a real functioning of the motor, and the actual decay and decrease in rotor speed is created by increasing packing of the electrodes themselves close to each other and electric discharge occurring between them as more electric current flows between electrodes then gets stuck on the rotor. And further to the torque, well, if I have the acceleration, I have the torque, friction torque, and therefore at maximum speed I know that they are equal.
So the reviewer has 2 minutes, 3 minutes to ask you guys some questions.
To the reporter, can you please go to slide number 9? And to the opponent, meanwhile, what would you expect when you have your electrodes perfectly perpendicular to the rotor? Is there a rotation?
No.
Okay, I agree on that, because then your charge is spread symmetric. And then a question to the reporter when he finds this page 19.
What was the
19.
What was it about?
19. It was your sketch where you draw the rotation speed over the tilt angle. Because it didn't vanish at 90 degrees, and I think it's obviously wrong. But let's continue. Because why doesn't it vanish at 90 degrees? Or does it?
What the do you ask me if it stops working at 90 degrees?
Yes.
No, it's not so.
Okay, I would definitely disagree. So, did you observe an oscillation of the rods and kind of sloshing around when you run?
Yes, there was a.
So you have a time-dependent variation in your distance to the electrodes, right?
Yes.
Have you accounted for this?
No. What we did do was we treated.
Okay. Upon do you agree with that? This is important. The distance of the electrodes in the rotor changes per time.
Distance between
Anyway,
electrodes and the
so
rotor?
you've stated that we've seen a logarithmic trend when we plot the angular velocity over the distance of the electrodes, right?
Yeah.
So for large distances we get a higher rotation speed.
No, like negative logarithm.
Isn't it rather 1 divided by r since it's an electric field of some kind of electric light?
A minus B logarithm distance.
Okay,
so
I
it's
think you have
decaying.
some fundamental misunderstanding. So, did you, how do you think your Van der Graaf generator changes or produces a reproducible voltage over time, or does it change?
No, so the Van de Graaff was allowed to first get up to its maximum.
And then have you some plot where you can show us the voltage over time, or the,
no, we did not.
do you think it's really reproducible? Yes or no, please?
No.
Okay, opponent, do you agree?
I believe that Van de Graaff generators can create constant voltage.
Okay, I disagree. Do you always observe arc discharges in your experiment?
No, not always.
Not
Just
always.
when the fall was
So could you run the motor on also only using arc discharges?
No.
Why?
When you discharge the charge, you're getting rid of the charge which will actually provide the force. The charge will flow from the Van de
I
Graaff
agree
to
with
the
that
ground.
because you have to charge on your surface. And therefore the last question, where is your charge? On the aluminium foil or on the plastic layer?
On the plastic layer.
Okay, I agree because you stated that the aluminium foil helps to keep charge and I didn't understand it correctly.
Well, may I next?
Probably not, we're out of time. Sorry about that, relentless. Okay, preparation recorded.
Hello, my name is Frederick Gardas and I'm going to do your position of problem number 1 Invent Yourself today. To the reporter. The reporter generally had a sufficient qualitative explanation which was nevertheless questionable in a few points because we didn't understand how the charge gets actually away from the electrode and we'll clarify that later. Finally, there was an investigation of many parameters and the optimization process of the rotor was presented. But it's questionable whether the Van de Graaff generator is suitable to produce a constant voltage over time, and it's unclear how he measures angular velocity. Furthermore, there are no quantitative model of charges, and there is a wrong basic of understanding of this, or this is quite wrong, excuse me. There is a missing qualitative explanation for ideal parameters, which is especially important for the tilt angle of the electrode, because there the reporter made a wrong statement, and we'll take a look at that in a moment. And also his trend of angular momentum versus time is quite dumb. Now, the opponent clearly clarified the generation of voltage by the Van de Graaff generator, and he pointed out the missing basic explanation, even though also his own explanation wasn't sufficient for me. So he didn't ask for bearing, which would be a possible optimization because friction could be minimized like this. And he stated the importance of the ion winds to be negligible, where I agree to the reporter because the ionic wind is really negligible and the main force which generates the torque is the Coulomb force. And also he didn't ask for the trend of the tilt angle of the electrode, and there is a fundamental misconception of both of them. To the discussion, the key question was the exponential velocity decay over the distance. So herefore, the reporter stated that the velocity of the rotor decays exponentially with distance, and the opponent stated that it's logarithmic. But in my opinion, it is approximately proportional to 1 by R, since we have approximately a line charge in the electrode, and therefore the electric field decreases proportional to 1 by R, and such although the torque decreases to 1 by R. And therefore I think both the exponential and the logarithmic trend are wrong. Therefore, there was a discussion on the corona discharge where has been discussed how it qualitatively works, where the opponent pointed out that it reduces the ionization energy in the field, and there are random processes like the photoelectric effect, which then ionize the gas particles. And we thereby agree to the opponent, since the critical electric field for this to take place can be found by the Peaks equation to be 5 times 10 to 7 volts per meter. Now, there was a discussion on the aluminium foil, where the reporter made not really clear where the charge is located, and one could misconcept it with whether it's on the aluminium foil or on the plastic, but it's definitely on the plastic, as the reporter also agreed to me in the end. Nevertheless, there was the missing expectation of the tilt angle, because if you had a perfectly perpendicular on the electrode, a perfectly perpendicular electrode to the rotor, then you get a charge sprayed away in all directions. And therefore you have as much as charge on the left as on the right. And therefore you have a symmetry and all forces compensate. And this means there's no rotation possible. And both the opponent and the reporter didn't clarify these points, whereas the reporter also told me that for 90 degrees of a rotation would still be possible. And I think this is definitely wrong, and the reporter could have investigated on this a little bit more. Now, finally, I think the task was partially fulfilled, since we did see an observation from some parameters, but the qualitative explanation both for the generation of the ion as well as for the trends, for the distance of the electrodes to the rotor, and for the tilt angle of the electrodes with respect to the rotor was not sufficient in my opinion, and I think both could have done better. Thank you.
Okay, we move on to questions from the jury panel. Oh, sorry, we've got 2 minutes. So we've got your 2 minutes final summary. Australia. Including remarks to the reporter.
Yeah. So firstly, we would like to address the measurement of angular velocity. So we recorded the cylinder moving around from a top on, and we used tracker to determine the angular velocity. We agree with the ionic wind comment, which it was negligible and was not enough to get a corona motor moving. I do agree now with the inverse proportional relationship with the force compared to the distance, as with Gauss's law, the surface area of the cylinder varies by 2 pi r/h, and the force will be inversely proportional to r. So overall, the problem statement asked us to optimize our experiment, and we did so by investigating the parameters that we could vary, and we further optimized our experiment by 3D printing a basic shell, which allowed us to fix keep the angles and the distances particularly fixed. As per the Van de Graaff, I agree, does not always provide a constant voltage. However, that was the scope of our equipment, and to sort of to make sure that it was kept relatively constant, the Van de Graaff was left running for a while before the actual motor was set in motion. That obviously did not keep it exactly constant, but it took away the initial build-up of charge and initial increase in voltage. Yes, thank you.
So now we have questions of the jury. 5 minutes. So, would you like us to I'll start with the questions to the reporter then. So the question asks you to optimize it and make a one that went as fast as possible. I think that was that. Okay. So your final model that you made, you 3D printed, you never told us how fast it went.
Yeah, so I was running out of time. It went at 10.45 radians per second.
So that was your optimum one?
Yes, that was all.
Yeah. Thank you.
For the opponent, can you comment on the reviewer about the damping and the friction?
on damping and friction.
Right, he mentioned that, the bearing.
Could you like state again what's your
So I've told that we weren't really sure how we took the bearing, and in general a pinpoint suspension is better because for a very low friction we also get a very high rotation speed. This is, since it's just a constant driving torque against the velocity, friction which is proportional to velocity.
we're doing that the like a point content is much more frictionless than a bearing. If that's what you're asking.
I would agree with the reviewer where just calculating the deacceleration after the motor has been turned off is not enough. As obviously the friction would
So the reporter, what is the maximum electrode that you can have for your model?
after we went up to 10 electrodes, it did not provide enough torque for it to actually rotate, and the optimal we found that was 4.
4?
So 4 total electrodes, 2 positive and 2 ground.
Oh, okay. So, so if you increase the radius, and then can you add more electrode?
Increasing the radius, yes, we could have, but
Will that help optimize your motor?
yes, it would. That's one of the restraints we had, was not finding something larger than the final optimized motor we had. So the final optimized motor we had, we did use the largest possible radius and largest possible container.
May I add to?
Yeah, I'm about to ask you.
I believe that changing the diameter affects the optimal speed, but there is an optimal diameter as it comes together to number of it compares number of electrodes and moment of inertia and electric discharge between electrodes. So there we can find optimal diameter of the rotor.
So the reviewer?
So in general is indeed that when you increase the diameter you could place more electrodes around the rotor. This generates a larger torque. And to find the optimum, you just have to look at the increasement of moment of inertia, and when you can keep this relatively slow compared to those electrodes, then you have increasing velocity with increasing rotor radius. Assume that you're placing more electrodes around it, because then you have a larger distance relative and therefore no mutual interference.
Maybe someone else.
Can you just ask a quick clarifying question for the reporter? So at which point in time you measure the angular velocity?
The final, after it had reached its, so we recorded the whole thing and we took the maximum at which it stayed constant.
So is it maximum or the one where it's constant?
The one where it was constant.
So for the reporter again, do you think you can find the torque on the friction from your experiment?
From the friction we did find the torque. It was, we found the torque due to friction, but we believe that the torque wasn't exactly constant while it was deaccelerating, so that wasn't enough to just tell us what the torque would be during when the motor was actually running.
May I comment?
Okay.
Yeah, because when you have your torque, it's generally proportional to the velocity. Since the faster you rotate, the more kind of slopes or inequalities in the bottom you have to pass, and therefore you get a high friction with high velocity.
The opponent, you want to say something? You have to comment something else?
Well, I did not plan to, but I can. I believe that if when they achieve 10 radians per second, I don't think that the friction changes that much, so they could calculate that much with the increasing velocity as they achieve really small velocities. So they could get the torque.
Sorry to stop you. Well done, guys. Ready to, not always ready to hospital, your fault. For Australia's presentation of the Corona motor. And my score is 4. So we have 5 and a 5 and 5 and 5. Okay. And the opposition in Slovakia is, oh, if you could read the board so we can write the names on that. We've got a 6 and 5 and 6. a 7, and a 6. And then the review, I've got a 6, and an 8, and an 8, and an 8, and a 9. So well done, guys. So everybody gave I think we gave 5 exactly. Someone want to talk about 5?
It was, I would have given a lower score, actually, but because was an attempt to explain a bit of the physics to start with, I gave it 5. However, there was no model in the presentation, and some of the opponents point out that even a simple model would work. These are all major formula, etc. So the quantitative analysis was missing, and there are some, in many points of the presentation there was not an explanation why things were presented, so I encourage you again to improve on that. So that's my 5.
So yeah, I guess my 4 is pretty similar really. It's very tricky. It's very tricky to do. And in a school where you have got access to a high voltage supply, which is guaranteed to be a certain voltage, is very difficult. But the band graph is a beast. It's a beast, and that should be addressed. And yeah. But in terms of looking at theory that you can apply, actually explaining basic physics, there were a few little things which you were talking about ionizing air atoms without, it's very kind of vague, and where the charge is going and what was causing it, and what were the forces involved. It was just not drawn out very clearly. So I'm afraid that's why I went down there. And then on to the opponent, feedback that we got a 7.
So, my 7 is, there was no physics attempt to analyze physics, and in the report, the opponent, to my point of view, tried to find the physics of the phenomena and explain. So, and in my estimation, the grade is 6.5, and I just round up. So.
Oh, so I gave the lowest score.
Yes, I think like some points grades were really good, but then on the other hand, I think the discussion went like too slow. Maybe the time management there could have been a little bit better, so that some of the points could have been addressed already by you. Instead, I was waiting for the reviewer to address some of the points that I was expecting you would address. So I think mainly that my score a little bit lower. But you started well, so just maybe a little bit more time management and focus on the discussion to bring all the points and discuss particularly angle.
I agree totally, sir. You had a good point, but you didn't push it through.
I just add to that, like, at a certain point, it's kind of switch to role a bit.
Yeah.
Like you become the reporter, and then the reporter asks you a question, and then you answer. Yeah. And then some of this line of the reporter is just critical physics equation that's missing, and then you didn't point it out. So you point it out, and we'll round you up. So I got you 6.5, but then round you down. Like yeah, I did previously another 5. So.
And review, you gave a 9.
I did.
No, I don't know who is in
I did. Yeah.
That's a 9, yeah.
Yeah. So I think when the reviewer did ask the question, and he did really good, like he asked the reporter and the opponent in parallel, and then it's like all the critical point about this problem that he addressed. Yeah, and then he even pointed to the graph that I have the same equation as well, like the 90-degree angle. So it's like, so he And then he have the missing point and the torque and the friction, stuff like that. So it's all the critical point to optimize the motor. Yeah.
Yeah. I thought it was a very workmanlike review. I guess I just kind of was just a little bit down behind you on most of those things. Thought it was reasonable questions and quite a good review, good speech and things. But there was a huge amount to go into in the review. We went through a lot of points that were lacking and hadn't been picked up and things like that. And I just didn't, I think you didn't get them all. I'm not sure about the 90-degree thing because I don't, theoretically it won't go, but in practice, you're never going to get it exactly so right.
So with my motor, there was no rotation. So no.
Yeah, well, I've also seen motors that were rotating really fast with a 90-degree electrode. Because you've only got to give it a little push and then it will keep spinning. And if it's not, anyway, that's what we've seen. But that was just a small program. Yeah, anything else anybody wants to ask? If you've got any other questions for us, again, please feel free to ask. I think we're ahead of some of the groups, especially the group 1. Those 1, 2, 3, 4 who were all in a group of 4 together. So we don't have to rush off for dinner, but it's 7:05. So we should give each other a round of applause. Bear in mind that 5 is the sort of average, so we've seen some very high quality work here.
I want you watching it.